Today I'm gonna talk about the solid of revolution. A solid of revolution is a solid obtained by revolving a region about a line. So you see that you have the region that bounded by the curve y equal to square root x. Okay, and you like to rotate this guy about the x-axis. So you're gonna obtain a bow like this one. So you see that it's gonna give you a bow that obtained from rotating this region. So you have this region and you rotating this one. You can rotate clockwise or counterclockwise, it doesn't matter. It's gonna have to be full circles, that's all. So in this case, we're gonna apply the idea of the volume of the solid by using the cross section. So you see that you're gonna find the volume of this solid by you see the cross section. So the cross section turned out to be circle. Okay, so it's a cross section. So the cross section is circle. So if you have cross section is a circle, okay, so a cross section is a circle, you're gonna be able to find the volume of this solid by just applying the idea of integrate the area of the cross section. So in this case, it's gonna be integral from A to B, and it's gonna be the area of circle. Okay, so it's going to be the area of the circle, dx. So this will give you the volume that you're looking for. Okay, so you will have the volume equal to integral from A to B of the area of the circle. So you have this one, note that the cross-section perpendicular to the rotation axis is a disc, okay, or a washer. So what does it mean for being a disc or a washer? So for being a disc, it's gonna be just a circle, okay, so it's gonna look like this one. So you have this one together with the center, and you have the washer. The washer turned out to be some kind of a donut. So you have inside and outside. So it's gonna give you such a ring like this one. So you have the center here. So the washer is this picture, and this is this picture. So you see the difference here, the washer turned out to be a donut that you're gonna have the inside circle and the outside circle. So this one is called washer, okay? And for the disc, it's gonna be just the whole circle. So what will be the area for the disc and the whole circle? So it's going to be just, you have the center, okay, you have the center, and it's going to be pi radius square, okay? So the first case that you have the this way, for the this way, let me copy and I'm going to put it down here. So for the this way, you're going to see that the way to find the radius will be pi time, the way to find the surface, the cross-section area turned out to be pi times radius square. And if you have the washer, okay, so if you have the washer, it's gonna be pi times outer radius square minus pi times inner radius square. Okay, so let me put it in the middle. It's going to be nicer like this one. If the cross section is the washer. So you have two cases, and then you just integrate ax dx or ay dy depending on the rotational axis that you have. So you first identify your rotational axis and you have to find the cross-section perpendicular to rotational axis. So another thing that I like to emphasize you is going to be about the perpendicular to rotational axis. Okay, so this one is perpendicular to the rotational axis. What does it mean? It means that you're gonna integrate from A to B, okay, and it's gonna be that you're gonna have the washer or you're gonna have the disc, and it's gonna be the cross section that you're gonna integrate from A to B, and you're gonna obtain the volume of the solid that you're looking for. Okay, so we like to find the volume of the solid obtained by rotating about the x-axis, the region under the curve y equal to root x from x equal to 0 to x equal to 1. So let me grab this picture for you. So you see this one that I'm gonna have to take screenshot here. Okay, so let me just take the screenshot for this one. And I'm gonna put it here. So you see from this picture that it's gonna be the interval A, B. So you have A equal to 0. Okay, so you have A equal to 0 and you have B equal to 1. Okay, so you have A equal to 0, B equal to 1. So you're gonna have the volume given by integral from 0 to 1 of your circle. Okay, so it's going to be your circle dx. Okay, so it's going to be integral from A to B. So it's going to be along the x-axis and it's going to be integral the circle. And what will be the area of the circle? So it's going to be the area of the circle. You see the center and you see the radius given by, so this is what you can see. Okay, so you're gonna see that the radius will be given by y. Okay, so this one will be your x. So you have your x and your y, and this will be your point xy, and this one is the parabola y equal to root x. So the parabola here is the parabola y equal to square root x. Okay, so you have y equal to square root x. So you have the point xy. So the radius in this case will be equal to y. Okay, so the radius will be equal to y. So it's gonna be integral from 0 to 1 of pi y square dx. Okay, it's kind of easy like this first. And then what? And then you're gonna not be able to integrate yet because you see you have dx here. Okay, so you have dx here, but this guy is y. So you need y square in terms of x. Okay, so you need to change to x. Okay, so you're gonna change this guy to be something in terms of x. So you're gonna solve for x here. So you have x equal to y square, and you're gonna just have y square is gonna be x. Okay, so you're gonna just integrate 0 to 1 of pi x dx. Okay, so you integrate from 0 to 1 of pi x dx. So this guy will be just pi, and you integrate x, you get x squared over 2 from 0 to 1. So you get pi over 2 to be your final answer. Okay, so this one will give you the volume of the solid obtained by rotating the curve y equal to square root x around the x-axis. You obtain a ball and you'll be able to compute the volume of this ball. Okay, so you have y, okay, and y equal to root x. Okay, so this is how we obtain the way to find the integral. Okay, so let me also emphasize also here that you have y equal to root x. Sometimes you may just, hey, why don't you just write root x? Okay, that's fine also. So for this one, some of you may just, hey, what is gonna be pi and root x squared? Can we do that? Of course you can, it is the same thing. Okay, so this one is y square, this one is root x square, so you end up with the same thing. Okay, so this one is the volume of the solid by the solid of revolution by using integral of the area of the cross section. Okay, the second question asks you to find the volume of the solid obtained by rotating about the line x equal to 1 of the same region in A. So let's have the region in A first. Okay, so this is the region that we have. Before we rotate this guy around the x-axis, now we want to rotate, sorry, so it's not going to be this region. This one is obtained by rotating the region around the x-axis. Now you're gonna rotate it about the line x equal to 1. Okay, so this is the difference. Okay, so it's going to be rotating about the line x equal to 1. So how could we do that? So we need to copy this picture first. Let me grab this one. Okay, so you see this region. Okay, so you see this region. You have y equal to root x. Okay, and it's going to be from 0 to 1. And you're going to rotate this guy around the line x equal to 1. So you have x equal to 1 here. Okay, so it's going to be x equal to 1. So you have x equal to 1. And then what? So you gonna have this line x equal to 1. Let me draw this one. Okay, so it's going to be line x equal to 1, and this one will be your rotation axis. Okay, so you're going to get the bow. However, this one will be like the bow that flip down. Okay, so it's going to be the bow that flipping down. Okay, so when you have the line x equal to 1, you're gonna rotate this one. So you have to like find the cross section. The cross section, the cross section that we have is perpendicular to the rotation axis. So in this case, it's gonna be y, okay? So it's gonna be the rotation axis. So it's gonna be, so we have a y, okay? So what does it mean? It means that when you have this rotation, when you have it perpendicular to, it's gonna be like this, and you see that it's gonna run in terms of y instead of x. So I'm gonna just fix my point y here. Okay, so you're gonna have to fix your point y, and let me erase this guy. Okay, it's not gonna be root x anymore. So let me first erase this one. I hope that should be okay. It's not okay. It's gonna be have to be lower. Okay, so okay, so you're not gonna see square root x in the same picture anymore. So you see that it's gonna be shoot, and this one will be your center. Okay, and the radius turned out to be this distance. Okay, so you have the center at x equal to 1, and the point that you have here is the point xy. See? So you have the point here is the point xy, and you see that x equal to 1, y must be 1 also. So you see that it's going to be the volume equal to integrate from 0 to 1 of the blue circle. Okay, so if you have the blue circle and then you dy. Okay, and you see the radius. What will be the radius? What will be the radius? R, that I'm going to put R first. For this radius, you see that it's going to be 1 here. So you have to measure the distance from here to here. So in order to measure the distance from here to here, it's going to be, you're going to have 1, which is on the right, subtract by your x, which is on the left. So the distance here equal to 1 minus x. With me so far, how I get 1 minus x is come from, you have 1 here on the right, subtract the point x on the left here. So in this case, okay, let me erase my x. So in this case, you're gonna project this x down, okay? So you're gonna have the radius r equal to 1 minus x. Okay, so this will give you this distance. And so you're gonna have integral from 0 to 1 of pi r square dy. Okay, so you get integral from 0 to 1 of pi, and the radius is 1 minus x. Okay, and you have dy, so it's going to be 1 minus x squared. Okay, so that will be my radius. Okay, and you see that what is x in this case? X, you solve for x here, you're going to have x equal to y squared. So you have x equal to y squared. So you have x equal to y squared. So you're gonna have integral from 0 to 1, 1 minus y square dy. Okay, so this is what you have here. And then you're gonna be able to just expand and find the integral. So you get pi, and 1 minus y squared is going to be 1 minus 2y squared plus y to the 4th dy. And you would integrate this guy. So it's going to be pi y minus y cubed plus y to the 5th over 5 from 0 to 1. So this will give us pi, okay, 1 minus 1. Okay, so this one will be 2y squared. Sorry, it's going to be 2/3. Okay, let me write this one again. So it's going to be minus 2y cubed over 3. Okay, and it's going to be minus 2/3, okay, plus 1/5, and you're gonna obtain the final answer in this way. So you get 1/3 plus 1/5, so it's gonna be 8/15. Okay, so that's all. Okay, so let me explain this one again. So you see that this one, you rotate about the x-axis, so you get the disc that perpendicular to the x-axis. The perpendicular thing means that you have this one perpendicular like this. And another thing is going to be you rotate this one about the about x equal to 1, and this perpendicular thing turned out to be in terms of y instead of x. So you're going to use dy here, and you're going to cover y from 0 to 1 in order to cover the whole region, and you rotate them more. Okay. So if I do one more thing for this example, you may ask me, hey, if I'm not gonna rotate this guy about the line x equal to 1, can I rotate this guy about the line x equal to 2 instead? Okay, can I just rotate this guy about the line x equal to 2 instead? Okay, so let me add this page and I show you. Okay, so if I do, okay, so this one must be C. This one must be C. I include one more page here, and this one, instead of x equal to 1, I say it's x equal to 2. Can we do that? Of course you can. Okay, let me paste this picture. Okay, so of course you can, and let me explain how to do it. So for this one, you see that it's gonna be, let me erase first. I erase many x that I have. Okay, and I will have to erase this x. Okay, so according to this picture, let me like draw the line to 2. Okay, so you have 0, 1, and you have x equal to 2 here. Okay, so you have x equal to 2, and you're gonna rotate this one. Okay, so you're gonna rotate this one around the line x equal to 2. So when you have this one, you see that you're gonna have the path, and you're gonna have some empty space. Okay, imagine that you rotating this guy, so you're gonna see that you're gonna get on another direction. So you have 3. Okay, so you have 3, x equal to 3. Okay, and you're gonna have 4. The picture turned out to be in this way. So you see that you're gonna have empty space both sides. And in this case, you're gonna have the whole thing become a hole here. Okay, so let me just imagine that you have a hole here. So you have a hole in the middle, and you have your port both sides. Okay, so you have your port both sides, and you have your hole in the middle in this case. So you're gonna obtain the what? You're gonna obtain the volume of the solid. by the washer method. So we need to use washer. So when you integrate, you're gonna see that the center, where is your center first? Your center is at x equal to 2, and you're gonna integrate y, not x, so it's gonna be from y equal to 0 to 1 of a washer. So the volume V turned out to be integral from 0 to 1 dy, and for this question, it's gonna be the washer. So like I said, I gonna have the green, okay, which is the outside layer of your washer, and the pink, like this, okay. So it's gonna be washer, right? So let me draw the picture like this, and another picture inside. Okay, so this one gives you the green, okay, and the inside is the pink one. So let me change the color of this guy a little bit. Okay, so let me change this one color to the green, okay, and I'm gonna change this color to the pink. Ah. So I not be able to change it. Ah, let erase. So in this case, you have this picture. Ah, so you have the green outside and the pink inside. See, and the center is the blue color. So you have the center. And you see that this one you're gonna have the center, and this one will be your first radius. Okay, so the first radius, so it's gonna be the inner. Okay, so the inner. So what is the inner? This guy is x equal to 1. Okay, so the radius r, small r here. So r here will be equal to 1. How would I know it's going to be equal to 1? Because I have 2 minus 1, and 2 minus 1 is equal to 1. And you have this guy. Okay, so you have the outside one. The outside one in this case is going to be y equal to root x. Okay, and this one is going to be x equal to 2. So it's going to be 2, and you have your x here. And like before, the radius that you have here is going to be r equal to 2 minus x. Okay, so it's going to be 2 minus x for my r. Okay, I cannot erase it, so I'm going to just write it like that. So in this case, you get 2 inside and outside. So you have the small r and the capital R. Okay, so for this guy, it's going to be integrate from 0 to 1 of pi capital R square minus pi small r square dy. So you're going to just plug in pi, and you have 2 minus x for your capital R. So you have your capital R, which is 2 minus x, okay? And you subtract by pi, your small r is equal to 1, so it's 1 square. Okay, so this is r equal to 2 minus x. Okay, so I have the color that I can, and you have this one is dy. And don't forget, you need to change this guy in terms of y. So you have x here equal to y square. Okay, so you have x is equal to y squared. So you end up with integral from 0 to 1 pi 2 minus y squared, okay, minus pi dy. Okay, so this is how we have the volume of the solid. And if you want to integrate this one, you're gonna just expand. So you're gonna integrate 0 to 1 and pi. You have 4 minus 4y squared plus y to the fourth minus pi dy, and you'll be able to get pi, and you have 3y, okay, minus 4 third y cubed plus y to the fifth over 5 from 0 to 1, okay, and then you're gonna just obtain pi 3 minus 4 third plus 1 fifth, and this will give you final answer. Okay, so you may leave your answer like this, or you just use your calculator a little bit. Okay, so this one will be washer. Okay, so it's going to be the washer that you're going to have your hole in the middle. Okay, so in this case you have your hole in the middle. Okay, so you have your pulse here. It looks like a washer, or sometimes some students call this thing donut. Okay, it is the same thing. So donut or the washer. The next one, you like to find the volume of the solid obtained by rotating about the x-axis, the region enclosed by the line y equal to x and the curve y equal to x squared. So you see that you have y equal to x, y equal to x squared. Let me put some color in order to ease the explanation. So you have your y equal to x. Okay, so y equal to x. So this guy is y equal to x. I'm gonna use the red color. Okay, and y equal to x squared. I would rotating this one, okay, around the x-axis. The thing that you obtain will be a picture on the right side, okay, and you see that the area of the cross section turned out to be a washer that has center at 0. So the center is here, and you see that the radius, the inside, so this one will give you the center, right? So let me project this one down for you to see. So you see that you project this guy, and you're gonna have the small r. The small r turned out to be this distance. So this one will be your small r. I'm gonna erase this letter R that stands for the region. Okay, so I'm not gonna use this one. So let me erase this guy out a little bit. Okay, so I'm gonna explain why you have the small r. Okay, so this one is the small r, and this one will be your capital R. Okay, so this one will be your capital R. Okay, so you have the capital R equal to x, and the small r equal to x squared. Small r equal to x squared. So you're gonna find the volume. So the volume will be integrate So you first have to know whether you're gonna integrate dx or dy. So you integrate d what? Dx, because here you see it's gonna be 0 to 1, right? And you see the perpendicular is perpendicular to the x-axis. So it's gonna be, you're gonna cut perpendicular the x-axis all the time. So in this case, you're gonna integrate the washer or over the dx. Okay, so let me take the screenshot here. Okay, so you take the screenshot for this one, copy, and I'm gonna paste it here. So this is how we gonna see this picture. Okay, so you take the screenshot, I take the screenshot, I have your AX, and from the picture, it's gonna be integrate from 0 to 1. Okay, and it's gonna be 0 to 1 dx. Okay, so it's gonna be integral from 0 to 1 dx. And then what? And then you're gonna set it up. So it's gonna be integral from 0 to 1 of what? Of pi, the capital R square. So I use the green color for you. So pi capital R square subtract pi small r square dx. Okay, so this is how you obtain the solution. And for this one, it's going to be pi outside and you integrate 0 to 1. And the capital R square is going to be just x square. Okay, subtract by the inside one, so you get x to the fourth, so it's going to be x squared and then square. So let me just put here like that, so it's going to be like a consistent way, and this guy will be pi integrate 0 to 1 of x squared minus x to the fourth dx. So you get pi and you integrate x squared, you get x cubed over 3. You integrate x to the fourth, you get x to the fifth over 5. Okay, and it's going to be from 0 up to 1. Okay, and you're gonna have pi 1/3 minus 1/5. Okay, so it's going to be 2/15. Okay, so it's going to be 2 pi over 15. So this will give you the whole picture for this example. And the thing that I like to emphasize will be you need to know that this one you integrate of the washer over the interval AB. And the washer, you have the radius outside square, subtract the radius inside square, multiply with pi. Okay, so that's all you need to know. If you not quite understand, try to rewatch this one step by step, how I get the inside and outside, how I have the cross section perpendicular to the rotational axis. The last example for this topic is going to be, we like to find the volume of the solid obtained by rotating the region enclosed by the parabola y equal to 2x squared and the lines x equal y equal to x plus 1, x equal to 0, x equal to 1. So this one not give you the picture, so we may have to draw the graph by ourselves. So you have y equal to 2x squared. This one is going to be the parabola open upward, and it's going to be moving from the origin to unit up. Okay, so this one is going to be the normal parabola y equal to x squared, and it's going to be 2 unit up. Okay, and this is how you obtain the graph. And y equal to x plus 1 is going to be just straight line. So let's first draw the graph of the function. Okay, so you have y and you have x. Okay, so you have y equal to 2 plus x squared. So this one will be like this, and y equal to 2 plus x squared, and you have y equal to x plus 1. So it's gonna give you a straight line like this one. Okay, so let me enlarge this one for you to see this guy easier. So you have y equal to x plus 1, right? Y equal to x plus 1, y equal to 2 plus x squared over the interval 0 to 1. Let me have 0, okay, and you have also 1 here, okay. And you rotate this guy about the x-axis. So first of all, let me copy this picture before I ruin it. Okay, so I'm gonna just have x equal to 1 like this, that I'm gonna drop this one down. Okay, so this one, you have 1. Okay, and I'm gonna copy this guy first, okay, before I ruin it, because we're gonna need this one for b. So you see the region turned out to be this green guy here. Okay, so this one is gonna be the region R that we gonna rotate. And the first question asks you to rotate about the x-axis. So you have your center here. Okay, you have your center here. So the center here, and you're gonna draw the inside, the inner. So this one will be your inner radius. Okay, and you have the outer one. Okay, so let me erase this R because it's gonna like confusing. Okay, so you have the inner one and you will have the outer one. So you have the outer one, which is this guy. Okay, so you have the inner and the outer. Okay, so you see that the analyst or the washer that you have, okay, so on the donut that you have, the volume turned out to be integrate from 0 to 1 of the outside. Outside in this case is going to be the blue circle. So this one is outside, and you have the inside is the red circle. Okay, so this one will be your center. Okay, so this one will be your center, and you have your dx. So you like to integrate from 0 to 1 of this donut. So it's gonna be the, where is the green one? The green one is here. Okay, so when you rotate, the path turn out to be this guy. Okay, so the green one. So in this case, it's gonna be pi capital R square minus pi small r square. Okay, so that my area of the washer or the donut. Okay, so this one is washer or donut. Okay, so you're gonna just integrate from 0 to 1, and you're gonna have to find the outer. What will be the outer? The outer turned out to be measuring from here to this curve. Okay, so it's gonna be from 0 up to 2 plus x squared. So it's going to be 2 plus x squared subtract 0. So that will be the outer. So it's going to be 2 plus x squared, okay, subtract 0. So this one will be your r, okay, so it's going to be outer. Let me write it down here. R will be 2 plus x squared subtract 0. And for the small r, for the inner, you see that it's going to be here. So it's going to be x plus 1 subtract 0. I subtract 0 because you are beginning at 0. What if you begin at negative 1? So if you have negative 1 here, and if you like to compute, it turned out to be x plus 1, okay, x plus 1. And instead of subtracting 0, you're gonna subtract by negative 1. You see that you're gonna get more distant. Okay, so that's the thing that I like to teach you here. I subtract 0 for you because we beginning at 0. Okay, you may argue that, hey, you subtract 0. You don't need to subtract 0. You need to subtract 0 because if you have other situation, like you have x equal to negative 1 and you rotate, you're going to get the new inner. And the new inner turned out to be x plus 1 minus minus 1, okay, that you can apply on your own. And the new outer will be what? The new outer will be 2 plus x squared minus negative 1. Okay, so you see that you have new inner and new outer if you rotating about the line y equal to negative 1. Okay, so this one is not, this one is not x equal to negative 1. It's going to be y equal to negative 1. Sorry, so this one is y equal to negative 1. And this guy will be x plus 1 minus minus 1. And this outer turned out to be what? Turned out to be 2 plus x squared minus minus 1. I want you to get this idea. Okay, this one will be important. So this one will be just, let me write the outer first. So this one is going to be x plus 1 minus 0. Okay, so you would get pi, and you have 2 plus x square minus pi, and you have x plus 1 square dx. Okay, and if you want to find the volume, the value of this guy, it's going to be pi integrate 0 to 1, and it's going to be 4 plus 4x squared plus x to the 4th minus x squared plus 2x plus 1 dx. Okay, and you may integrate by just term by term. First combine, you get x to the 4th, okay, minus, or it's going to become plus 3x squared minus 2x, okay, so minus 2x, and it's going to be plus 3, okay, dx. And please integrate this one. So let me integrate this one. So it's going to be x to the 5th minus 5 over 5, okay, and you're gonna have 3x cubed over 3 minus 2x squared over 2 plus 3x dx. Okay, so you see it's not that bad number. So from 0 to 1, okay, so it's from 0 to 1. So it's going to be pi, and it's going to be 1/5 plus 1 minus 1, okay, and you're gonna plus 3 Okay, so it's gonna be 3.2 pi, okay, for this volume. Okay, so this is not that bad number. Okay. Ah, for B, you are about the line y equal to 3. Okay, so you are rotating this guy about the line y equal to 3. Let's first write down the solution for y equal to -1 that we mentioned before. So here, if you have y equal to -1, okay, so if you rotate this guy about the line, okay, so this one, volume equal to, okay, so volume about y equal to -1. Okay, so like I mentioned earlier, so it's going to be integrate 0 to 1, and it's going to be pi 2 plus x square minus 1 square, and minus pi, you have x plus 1 minus 1 square dx. Okay, so you see that you have extra factor -1, and this is how you obtain the volume. How about if you rotate this one about the line y equal to 3 instead? What will change? So the thing that will change turned out to be, let me draw this one a little bit longer. So you get this. Okay, so this one, and you have y. Okay, and you see this is my 1, this is my 2, right? This is my 2, and my 3 is here. Yeah. So you have 2 up there, and you have 3. So let me, so you're gonna rotate this region. So you rotate this region like this. So this one is y equal to 3, and this is the green region that you rotating. And if you rotate this guy, okay, so if you rotate this guy along the line y equal to 3, what will be different in this case? Actually, I don't need this guy longer, right? Sorry. So it's gonna be just my y here. So you see that if you have this one, the center is here. Okay, so the center. So the center is here, and you see that you're gonna get kind of bow in this case. So you're gonna see that the center, you're gonna have the volume given by integrate from 0 to 1, and you see that this y equal to 2 plus x squared turned out to be inside, and y equal to x plus 1 turned out to be outside. So in this case, the picture changing a little bit. So you have the blue color inside, and you have the red color outside. Okay, so you have the blue inside, the red outside, different from the previous one that you have the red inside, the blue outside. So this one is the green one. Yeah. So you draw this guy. Okay. And then what? Done. So, and you see that you're gonna integrate this one, and it's gonna be dx. Okay. And you need the inner and the outer, the inner and the outer. So this one will be your inner, this one will be your outer. Okay, so this is how we obtain this one. And you're gonna have here, it's gonna be what? It's gonna be the capital R given by, okay, so it's gonna be the higher one subtract the lower one, higher subtract lower. So it's gonna be R equal to 3 minus x plus 1. Okay, so it's going to be 3 minus x plus 1, which is your the capital R. For the small r, it's going to be this curve. Okay, so for the small r, it's going to be this guy. So for the small r turned out to be the small r equal to 3 subtract by the 2 plus x squared. Okay, so it's going to be 2 plus x squared. So r equal to 3 minus 2 plus x squared. Okay, and you're gonna just have the integral that you're looking for. So it's going to be pi, your capital R, which is 3 minus x plus 1 square. So this one represent your capital R minus pi, and you have your small r, which is 3 minus 2 plus x square, and you're gonna square this one, and this one is your small r. Okay, so you get pi, and this one turned out to be 2 minus x. Okay, so it's going to be 2 minus x square, and it's going to be pi, and it's going to be 1 minus x square, and you square. And don't forget that you still have integrate from 0 to 1. So you integrate from 0 to 1 dx. Okay. So in this case, you're gonna have to expand again. So pi is gonna be 4 minus 4x plus x squared minus pi, and you have 1 minus 2x plus x squared dx. So you get pi, and it's gonna be 4 minus 1, so given by 3. Okay, and you have negative 4 plus 2, so it's going to be negative 2x, and you have x squared minus x squared. Okay, so you have x squared, sorry, it's not x squared, I make mistake, it's going to be x to the fourth. Sorry. Okay, so you see that it's gonna be 3 minus 4x, okay, and you have x squared minus x to the fourth, so it's gonna be minus x squared, and you have minus x to the fourth dx, and you're gonna integrate this one, so it's gonna be pi, you have 3 minus 2x square minus x cubed minus x to the fifth over 5 from 0 to 1. Okay, so it's going to be from 0 to 1. So that will be my final answer. So it's going to be 1 minus 2, 15, right? So it's going to be 1 minus, so it's going to be 7 over 15. Okay, so you use your calculator. So it's going to be 1 minus 1/3 and minus 1/5. So it's going to be 7 over 15 for your final answer. Okay, so that's all for this video and this topic. So you see that it's gonna turn out to be kind of messy for integral. Sometimes some question ask you to only set up. We're gonna see that in the next video that the question asks you to just set it up. However, for these two questions, the question asks you to find the volume, so the answer must be in terms of number. So you not be able to avoid it. Okay, so this is how we obtain this solution. Okay, I have plenty space on the next page, but I didn't use it. Okay, so this is the thing that I would want you to understand. We're gonna do more example on this one next and later. And the next video still on the volume, but it's gonna be another method, which is called the cylindrical shell, that will be different from the thing that we study in this script. This one is called washer or this technique. Okay, so I would stop here.